Let's talk about the most powerful, most efficient computer on the planet. And no, I'm not talking about some new billion-dollar AI from a tech giant. I'm talking about the one that's sitting right inside your head. It's one of the biggest puzzles in tech today, and to really get it, we need to take a quick trip into the very near future.
So, picture this. It's January 2026. We are deep in what everyone is calling the power crunch. Every single week, it seems like another massive new data center is getting built. And these aren't just warehouses full of servers. These things are absolute monsters, with some of them sucking up enough electricity to power a small city, all just to keep our AIs running.
So you have to wonder, right? What would it actually take, with the tech we have now, to build an AI that could simulate a human brain? Well, get ready for this. You'd need to link up 18 million laptop processors and run them all at once. And the power draw? A mind-blowing 2.7 billion watts.
I mean, just look at this chart. It's almost funny, right? That giant bar on the left, that's the AI simulation. We're talking nuclear power plant levels of energy. And that tiny, tiny little sliver next to it? Yeah, that's you. That's your brain doing an infinitely more complex job. The sheer scale of this difference, well, that's the whole story.
Let's put this into an even starker comparison. To get an artificial intelligence to try and be a brain, you need a nuclear power plant. Your actual brain does the real thing on just 20 watts. That's literally the same amount of energy as the dinky little light bulb inside your refrigerator. It's just incredible. So when you do the math, it turns out your brain isn't just a little more efficient. It is 135 million times more energy efficient than our absolute best attempt to copy it with a computer. The performance gap is so vast, it's almost hard to comprehend.
And this, of course, leads us to the billion-dollar question. How on earth is this possible? Why is our most advanced technology, our precious silicon, so unbelievably hungry for power compared to the biological hardware we're all walking around with? Well, the answer lies in a fundamental design flaw that goes back decades.
You see, this insane energy gap isn't because of some brand new problem. It comes from a design choice that's been baked into the architecture of pretty much every single computer for the last 70 years. It's called the von Neumann bottleneck. And here's the basic idea. In almost any computer, the memory, where all the data is stored, is physically separate from the processor, the part that actually does the thinking. This separation creates a constant, massive traffic jam for information.
So for every single tiny calculation, the computer has to fetch data from memory, shuttle it down a physical wire to the processor, do the calculation, and then shuttle the result all the way back. That round trip, that physical journey, wastes an unbelievable 90% of the energy just as useless heat. It is the very definition of inefficiency.
Now let's compare that to your brain. This is where biology is just so much smarter. In your brain, the synapse, that little connection point between your neurons, is both the memory and the processor. It's all in one. There's no separation. The data doesn't have to travel anywhere. The computation happens right where the information is stored. It's beautiful. It's elegant.
For years, the brute force solution in AI was just more data, more power. But a very recent discovery has completely changed the game. It gives us a new path forward, and it's inspired directly by the brain's brilliant design. On January 4th, 2026, researchers at Johns Hopkins University published this study that sent shockwaves through the entire AI world because they decided to stop focusing on bigger data sets and instead started focusing on a better blueprint. And here's the absolute kicker. When they built an AI whose architecture mimicked the brain, when they got rid of that bottleneck, it started behaving intelligently even before they trained it on any data. That means the blueprint, the design itself, is the secret sauce. Okay, so what does this all mean for us? You know, in a world where AI is getting more powerful by the day, this discovery actually helps us see our own unique and totally irreplaceable role in all of this. This table really breaks it down. AI is a phenomenal optimizer. You give it a well-defined problem, and it will find a solution with incredible speed. But our role is totally different. We're the architects. Our core skill isn't just solving problems, it's finding new and interesting problems to solve in the first place. I love this quote from the CEO of Perplexity. It really hits the nail on the head. That spark of curiosity, you know, that little itch in your brain that makes you ask why or what if, that's the human part. That's the original signal that an AI can only amplify but never create on its own. So the next time you hear about some incredible new AI, just take a second and remember your own 20-watt hyper-efficient supercomputer. AI is a fantastic tool for finding answers, no doubt. But you are the architect. You're the one who asks the questions. The real challenge moving forward isn't competing with AI. It's deciding what truly interesting problems you'll choose to find.